Welcome to Chapter 3, Concrete Work Measurement Example. In this example, we will measure lean concrete, footing concrete, column concrete, and grade beam concrete for a small foundation layout using standard quantity surveying rules. The building foundation consists of 4 isolated footings named F1, F2, F3, and F4. Each footing supports one column, named C1, C2, C3, and C4. All columns are located at the center of their respective footings. Footings F1 and F2 have sizes 1.6 by 1.5 meters. Footings F3 and F4 have sizes 1.5 by 1.5 meters. The depth of all footings is 0.3 meters. Columns C1 and C2 have sizes 200 by 300 millimeters. Columns C3 and C4 have sizes 300 by 400 millimeters. The height of all columns is 1.2 meters. Lean concrete of 50 mm thickness is provided under all footings and is measured in square meters. 4 grade beams connect the columns. GB1 connects C1 to C2. GB2 connects C1 to C4. GB3 connects C3 to C2. GB4 connects C4 to C3. The depth of all grade beams is 200 mm. The widths vary according to the structural drawings. Step 1 is the measurement of lean concrete area. Because the thickness is less than 100 mm, lean concrete is measured in square meters. For footings F1 and F2, the area of one footing is 1.6 multiplied by 1.5, which equals 2.4 square meters. For 2 footings, the total is 4.8 square meters. For footings F3 and F4, the area of one footing is 1.5 multiplied by 1.5, which equals 2.25 square meters. For 2 footings, the total is 4.5 square meters. The total lean concrete area is 9.3 square meters. Step 2 is footing concrete volume. Footings are measured in cubic meters. The formula used is length multiplied by width multiplied by depth. For F1 and F2, volume equals 1.6 multiplied by 1.5 multiplied by 0.3, which equals 0.72 cubic meters per footing. For 2 footings, the total is 1.44 cubic meters. For F3 and F4, volume equals 1.5 multiplied by 1.5 multiplied by 0.3, which equals 0.675 cubic meters per footing. For 2 footings, the total is 1.35 cubic meters. The total footing concrete volume is 2.79 cubic meters. Step 3 is column concrete volume. For columns C1 and C2, the cross-sectional area is 0.2 multiplied by 0.3, equal to 0.06 square meters. Volume equals area multiplied by height. 0.06 multiplied by 1.2 equals 0.072 cubic meters per column. For 2 columns, the total is 0.144 cubic meters. For columns C3 and C4, area equals 0.3 multiplied by 0.4, which equals 0.12 square meters. Volume equals 0.12 multiplied by 1.2, equal to 0.144 cubic meters per column. For 2 columns, the total is 0.288 cubic meters. The total column concrete volume is 0.432 cubic meters. Step 4 is grade beam concrete volume. The formula used is length multiplied by width multiplied by depth. For GB1, volume equals 4.2 multiplied by 0.2 multiplied by 0.2, which equals 0.168 cubic meters. For GB2, volume equals 3.3 multiplied by 0.3 multiplied by 0.2, equal to 0.198 cubic meters. For GB3, volume equals 4.2 multiplied by 0.4 multiplied by 0.2, which equals 0.336 cubic meters. For GB4, volume equals 3.3 multiplied by 0.3 multiplied by 0.2, equal to 0.198 cubic meters. The total grade beam concrete volume is 0.9 cubic meters. Step 5 is the total structural concrete volume. This includes footing concrete, column concrete, and grade beam concrete only. 2.79 plus 0.432 plus 0.9 equals 4.122 cubic meters. To summarize the solution, lean concrete area is 9.3 square meters. Footing concrete volume is 2.79 cubic meters. Column concrete volume is 0.432 cubic meters. Grade beam concrete volume is 0.9 cubic meters. Total structural concrete volume is 4.122 cubic meters. This example explains the standard method of concrete work measurement for Chapter 3. If you found this useful, like the video, subscribe to the channel, and practice similar questions for exams.